Okay, we're going to do a three-dimensional development, complex development, transition piece, and we can see here we're going to use the top one here. Later on we're going to do a half development on this one, but this is the one we're going to be working with. As you can see, it's in third angle orthographic projection. So this is a top view, and this is going to be our front view. And we're going to do a full development, which basically means we're going to unwrap this object so that if we want to fabricate it from sheet metal or from some sort of flat material, we'd be able to construct it. So, first thing you need to remember in this process is I'm hoping that you've remembered the two rules. And the two rules are, and we'll be going over this same rule over and over and over again, so hopefully the penny will drop. But the first rule is rule 1, which is if it is a point view in one view, then when I say if it, I should be saying if the line, okay, is a point view in one view, then in the other view, it is a true length. Okay, now that's a long sentence, okay, but all that means is basically if you're looking at the end of the line and you just see a little dot, say in this view here, then obviously when you look at it and that line becomes this line here in a top view, the point views are always going to become true length in the other view. So if you had a point view in this diagram, it will be a true length here. If you have a point view here, it'll be a true length in this diagram. Okay, that's the first rule you've got to remember, the point view rule. Point view of a line in one view is going to be a true length of the line in the other view. And then the other rule, which is rule number 2, I'll write it over here. Rule 2, which is if the line is perpendicular to the viewer in one view, then in the other view, it is a true length. So what does that mean? That basically means if the line is perpendicular, so what you're going to do is imagine that there's a person here, that's the back of their head, that's their big ear sticking out. If they're looking at this object, okay, any lines that are horizontal to him, okay, in the other view are going to be true lengths, okay, so that's a true length because that line is horizontal. That's a true length because that line is horizontal, perpendicular to the viewer. So you take a line of symmetry through the viewer, and if your line is perpendicular to the viewer, which is these lines here, okay, then you know that in this view they're going to be true, and vice versa. If it's perpendicular in this view here, then it's true length up here. Okay, now if you remember those rules, you should never ever be wondering whether a line is true or whether it's not a true length. Okay, enough of that blabbering on. What we need to do, first step, is we need to label our diagram. Okay, you decide whether you're going to go clockwise or anti-clockwise. I've decided I'm going to go clockwise, and I'm going to put letters on the top surface and numbers on the bottom surface. So I'm going to go this corner, this corner, this corner, this corner. I'm going to label them A, B, C, D so that's the top surface, which we can see is a square. And then on this surface here, on this bottom surface, I'm going to start this corner again. I'm going to label clockwise numbers 1, 2, 3, 4. Okay, that's step 1. So remember your 2 rules, and then you label your sides by taking each corner's top and bottom. Okay, so step one, label. Okay, you've got to get used to that process of labeling. So the top surface is letters. Okay, letters, and it's a square, and the bottom surface is a bigger square because we're going to a bigger square, and that was numbers. Just like we've done here. Letters on the top surface, which is this surface here. Numbers on the bottom surface. Now we need to label these corners. Okay, now when you take this object that you've got a top view and you tilt it up so you get a front view, which means you're looking at this bit here. Okay, when you tilt it up, okay, what's going to happen is you're going to see an end view of this line here, and that's what we write down on this corner here, 1 and 4. That's a point view. So if it's a point view in this view, then 1, 4 is a true length in this view. And this is a point view as well. This becomes 2, 3. And this top one becomes D, A. It's a point view. So DA in this view is a true length. And in this one here, we can see the CB end on. Okay, so go C, B. Okay, so we've now labeled our diagram with letters and numbers. On the top surface is letters, bottom surface is numbers. You've got to get used to that convention, okay? Once you've done that, step 2 is extend lines from front view. And we've done this in our previous example too. So we just pick our bottom line and we draw a line out, and then we pick our top view and we do the same, line out. You can see on this page that I haven't quite got my drawing straight, so just make sure that you line up those lines with the bottom and the top. And then you're going to go create a right angle, and all your true lengths that you need to find are going to be drawn over here, and you can label this if you want true lengths. That'll remind you what you're using this for. So all pretty good so far. Now you need to decide on a line that you're going to start your whole process for drawing your development, and I'm going to decide to use this line 1A. Okay, now the only trouble with that line is that it's neither a point view or perpendicular to the viewer, okay, in any of the views. Okay, so if you look at 1A on this diagram here, it's not perpendicular to the viewer and it's not a point view, so it's not a true length. How do you find the true length? You always go to the top view, you take your compass. Now if you were to go a 1A and then do the swing here, you're going to get it wrong. Okay, you've got to remember that to find that true length, we go to the top view and we put our compass between the 1 and the A on this top view. Okay, so it's a way of measuring it with the compass. Then we take our trusty compass and we swing an arc here. Now we've got a point there, and that's going to give us our line length for 1A. Now it's also going to give us our lengths, all these other lengths, because this is a symmetrical shape. So we can also say it's going to give us 2B, 3C, and 4D. Okay, so we've already found out a lot of information about this diagram. So now what I'm going to do is you could measure this line if you wanted. There's a number of ways you could do it, or you could create a dot, then grab your compass, and from that dot you could swing an arc. And then from here, let's make it really easy. Let's just measure it. There is a way of swinging to find 2 points, but let's make this process really simple. You're going to be looking at on here. Just measure it as accurately as you can. It's going to be 4 centimeters. Okay, so we're going to go 4 centimeters. That's our first line, and we know that that line is going to be 1 at the bottom, because the bottom surface has numbers on it, and A at the top. Okay, so we're looking at that line there. Okay, that's our starting point. Now we need to work out, we're just going to go from A across the top of this shape, okay, because the top is going to be letters and the bottom is going to be numbers. So we're going to go A to B. Okay, so is AB a true length? Well, if you look at AB on this shape here, it's perpendicular to the viewer. So we know that in the other view it's a true length, and vice versa. This is perpendicular to the viewer, so you could go down here, you can measure it off either. So we know that is a true length. Okay, so that's great. We can just put our compass between A and B, and we can swing an arc. Now, like I said before, swing your arc nice and big, and if your compass has a bit of a wander, you might want to just reset yourself and go again. Now I haven't got a proper compass here because I've got a pencil that's been tied to a set of dividers because I've lost my compass. So not a good start. But you swing a big arc, and now we know somewhere along there is B. Somewhere along this arc is B, but it can be anywhere along this arc, because it's like this it could be here, it could be here, it could be here, it could be here. We don't know where it is on that arc, so we need another arc to cross that arc. So we found and this is where the triangulation happens in. So for this thing here, step 3 is really going to be about swing an arc and triangulate. And triangulation is any of these sides that are sloping away from a vertical or horizontal, you need to triangulate. So we need to find another point that goes from 1 to B. Okay, so we've gone A to B, and we need to find another point, and we've only got one other point we can use, and that's 1. So we're going to go at the point, we're going to find the length of the line 1B. Now, because this is a symmetrical shape, any of the triangle lines in this shape are going to be the same length. Okay, so 1B, 2A, 4A, 1D. So once you find one of them, you're going to know all of them. And what we do is, it's the top view. So we've triangulated the face in the top view. We get a length, just like we did when we found this length here. And we swing an arc to find our true length. And once we've swung our arc, we draw our true length. Okay, now we're going to measure it, and we find out that it is 5 centimeters. Okay, so we know it's 5 centimeters. So what we do is we set our compass on here, and we're not going to need to really measure it, because once we do our 2 swings, we'll get a point that we can go to. It's 5 centimeters. We're going to put our compass on. We're going to swing our arc. So our first line happens there. And if you were to measure between here and here, it should be 5 centimeters long. Okay, which it is, 5 centimeters. Okay, so we swung our arc, we've got our point. We can now go A to B. So you should be following me along and stopping this video and starting this video each time we do one of these swings. Now we've done A to B, we need to go 1 to 2 on the bottom. Okay, on here, because we're doing this, we're working on this side. So we're going 1 to 2. You can see that this is perpendicular to me, so 1, 2 is a true length. Same deal here. If I look at this view, 1 to 2 is I'm looking, my axis of symmetry this way. 1 to 2 is horizontal line. In the other view is going to, so I can measure off this one or this one. It won't make any difference. We're going to use the top view, be consistent. 1, 2, we know it's a true length, so we can just swing an arc from 1, make your arc nice and big. That's my first arc, but I don't know. I need to swing another arc to hit this one. Okay, now we've got our point 1. This is the arc for 2. We need something that goes from A to 2. Okay, so A to 2 is this line here. So we can triangulate this face again, A to 2. Okay, so you can virtually triangulate all of these faces now because you know that the shape is symmetrical. So it's going to make your life a hell of a lot easier. Now, if you want to make sure it's symmetrical, you can measure this side and you can see that it's 5 centimeters. See that that's 4 centimeters. How long is this? 4, so yeah, so it's a square. Okay, so all of these lines, these triangle lines, the first one we did was 1B, but 1B is going to be the same as A2, etc., etc. All of those triangular lines, the triangulation lines, are going to be the same length. So we can now take our true length of A2 of our true lengths graph, because any line that's inclined is not going to be a true length if you take it off the diagram. Draw that, and that's going to give us point number 2. So now we've got one face done already. Now I'm scared I'm going to run off the page, but if I do, bad luck, that's where the video will stop. Okay, so now we need to go from B to C. Okay, now BC is a point view in this front view. Okay, point view, it's going that way. So BC is a true length in the other view. That's rule number 1. So we are going to go pick up our line length from the top. We're going to swing our BC arc. So that's our C arc, but we need another line that runs to C from 2. And you can see 2C, which we know is going to be this long line here, okay? Because we said all of these triangulations are the same length. So we're going to get 2C. Put our compass on 2. Swing our arc. That wasn't very accurate, was it? Which is there. So that's point C. Can you see how the angles can be quite extreme? Okay, we're going to run into our steps over here, and I'll rub them out if I have to. Okay, then we're going to go 2 to 3. 2, 3 is an end view in this diagram. So it's an end view in one view, in the other view it's a true length. So 2, 3 is going to be a true length. So we don't need to go over here for it. Okay, so 2, 3, swing our arc. So it takes us to 3. The arc somewhere along here is our 2, 3 line. So we need to find another line that runs from, we're going to go from this corner here, which we know. Now that is the line 3B. And all of these triangular lines are the same. So we can grab our compass to get 3B. Sit our compass on B, swing our arc. And that's going to give us 3 just here, where those 2 arcs cross. Draw a line. Panel number 2. Okay, now we're going to go from C to D. Okay, it's perpendicular because it's horizontal to the viewer. So in this view here, it's true. In both views, it's true. Okay, because this is horizontal, perpendicular to the viewer. So in the other view, it's going to be true as well. So we know that it's going to be a true length. So that is CD. So we're going to swing our arc from C. that'll get us to D, but we need to go from 3, that's 3 to D, okay? And that's this line here. But we know, like I said, that all of these lines are going to be the same, 3D. So what I need to do is grab my length off my true lengths graph, sit my compass on 3, swing my arc, and that's my point D. And then we need to go from 3 to 4. Now we know 3, 4 is a true length because it's perpendicular to the viewer in both of them, in fact. So we can go off the top. So arc for 4. So how do we get from, we need to go from C to 4, which is here. So we could triangulate all our faces in our diagram if you wanted to do this quickly and just put them all on our true lengths, and you might or might not need them, but really it's a good idea to think about the ones you need. Okay, so which might be all of them. So we need to go 3 to D. C to 4, which is here, which is up here. So that means if I've got my C4 arc here, because we want to get to 4, that's our C4 arc here. That means my last arc wasn't long enough. So if you don't make your arcs long enough, you can get yourself in trouble. Okay, so that was my, we were going from 3 to 4. And this, so we need to get 3 to 4 again, and swing that arc so that it crosses this arc. Okay. So we'll just double check that again. We went from C to D, and C to D is a true length. So we swung our arc. And that gave us our D arc, but I shouldn't have drawn a line, I don't think, because I went C to D, but then I need to work out where something else that crosses the D, which is the 3D, which is here. I don't think I did that correctly. Oh no, I did. I swung it from here. Sorry, I did do that correctly, which is why I drew it. Anyway, that's a D. So that line was correct. Which is why it pays to be really systematic in this whole process. We need to go from 3 to 4. I've labelled that B. I should have labelled that the 4 line. That's why I've confused myself. Because that arc is the 4 arc. Okay, we need to know what else goes to 4. And we decided we were going to use, we could use C4, okay, which is, let's C4, which is this one here. So we go C4 because it's one of the triangle lines. This one running across this triangle, and hopefully when we do this, that crosses there. Okay, that's a C4 line. Okay, what else could we use to go to 4? Could we use anything else? We could use D4, maybe. If we use D4, let's just see if they agree, just out of curiosity. And lo and behold, if we use the D4, they'll be very close. If I swung the D4, yes, okay, so you can see you can use more than one point once you get to a certain point in this diagram, okay? But you only need to get across 2 arcs to do this. So that's our point number 4. And now we can join those 2. So we've got 3 panels. We need one last panel. So we need to go back from D back to A. Okay, so DA is a true length because in the bottom view it's a point view. So we can just grab DA and swing our arc. I think we're going to make it just, okay, DA. And then we need to find a line that runs from 4, okay, because that's the null point that we've got down here. So I'm going to go 4A, and we know that 4A is going to be this line here, okay, because it's one of the triangle lines. For A, which is that point there. Okay, let's draw it in, and then we need to go from 4 back to 1. Okay, and 1, 4 is an end view here, so it's a true length in the top view. So we grab it. And we swing our 4 to 1 arc. Big arc, swing. Okay, and we need to swing from D to 1, okay? D1. So notice we've crossed every single one of these inclined faces. So you could start this process if you've got a symmetrical diagram by doing them all. But you know once you've got one, if it's symmetrical, that that's 1D. They're all going to be the same anyway. So we're going to go D to 1, swing our arc. That's our intersection point. We just made it, okay? So that is our diagram. To my thinking, it doesn't look right because it looks like this length here is too short. So we may have made an error in this panel here. So 4 to 1, 1, 4 is a true length. One 4 is a true length, and then we need to go from D to 1. So it's definitely that length. Swing from D to 1, and look, lo and behold, we found our error. Now, how did I know that I got that wrong? I know I got that wrong because this seam had to be the same length as this seam. If it wasn't, we were in trouble. So that's using a little bit of acumen in finding errors that you've made. Okay, if it don't look right, if you imagine folding it up and it's not going to fold up correctly, you have got it wrong. Okay, so there are your 4 panels, 1, 2, 3, 4, and if you were to close it up, you'd end up with that shape there. Tick, and you can check the answers. You need to be really careful when you're doing this. Don't use a compass that's made from a pencil that's been sticky taped to a pair of dividers. If you got a nice compass that's nice and tight, sharpen your pencils. Don't do what I've done. Sharpen all your pencils. Get a good rubber, and you'll make your life a lot easier. But hopefully that demonstration is going to make it clear that if you're systematic with these rules and you understand them, then you're going to be able to do these problems. Keep stopping and starting. Label first. Get your true lengths down and start the process, okay? Practice will make this easier.